Once we've accessed energy data from different sources, the next step is to prepare it for analysis, and this often means processing and harmonizing datasets. Raw time series data usually isn't ready to use straight away. Difference in resolution, format, or even missing values can all introduce inconsistencies that need to be addressed. Let's look at a few practical techniques that are commonly used to get energy datasets ready for simulations or decision making. An important task is harmonizing multiple years of data. For example, if you have 5 years of PV production data and you want to build a single synthetic year that represents typical conditions, you can use clustering algorithms like k-means or k-medoids. The idea is to group months or days across the 5 years into similar types and then select representative periods from each group to form a new synthetic year that is often called a TMY, or typical methodological year. This TMY maintains the seasonal and statistical characteristics of your dataset, but compresses it into a manageable 1-year time series. It's widely used in PV yield estimations, building energy modeling, and techno-economic analysis. There are several approaches to building a TMY. One of the most simple is to first extract monthly data from each year, cluster them based on total energy, variability or irradiance shape, and then select the most central months, often the medoid, as the typical one for that month. You can then combine the 12 selected months into a full year dataset. This process has 2 big advantages. First, it keeps the structure and dynamics of real data, and second, it avoids extreme outliers, which can distort simulations when you only rely on a single real year. If you want to conduct a more sophisticated analysis later on, you can combine the months differently and quantify opportunities and risks of your project. Lastly, harmonization also means being consistent in units, time zones and formats, especially if you are combining data from multiple sources. Always check your power values, that they are in watts or kilowatts, and if your time steps are in UTC or local time, and whether the intervals refer to the start, middle or end of the hour. Misalignment in these details can lead to large modeling errors, and they are easy to miss if you're not careful. In summary, processing and harmonizing energy data sets isn't just a technical detail. It's essential to ensure your models and decisions are based on reliable, comparable and realistic inputs. Whether you're interpolating high-resolution curves, generating a TMY with clustering, or just making sure your time zones match, these steps form the foundation of everything that comes next. In the next models, we build on this process data and begin using geospatial tools like QGIS and Python to analyze and visualize energy data.